Okay, so notes 1.3 talks about a tabular representation and summary statistics for one categorical variable. And so the first thing we're going to talk about is frequency tables. So it says a frequency table is a way to display how many individuals fall into each category of a categorical variable. So I would make sure to highlight that, how many individuals fall into each category. Remember, if you don't have a highlighter, I have them in the pink baskets in front of you, or you're more than welcome to use your own. So notice here, we're only talking about categorical variables. So for this notes, we're not using quantitative. Okay, so all the data that we're collecting here is going to be a category. So next definition is frequency. So it says frequency is also referred to a count. Okay, so if you're asked to find the frequency of something, that's the same as counting how many individuals there are. It says below is raw data of a sample of teachers' favorite pizza toppings. The term raw data is used when referring to data that is unorganized. Okay, so I would highlight raw data, unorganized. Okay, so most data that you see before a statistician touches it is raw data. Okay, so when you are going to start collecting data, when you develop your own surveys, that is raw data. Okay, once you analyze that data and make a conclusion from it, then that is data that is used towards a investigative question or a hypothesis. So notice here we have all these different pizza toppings. Okay, it says while the raw data gives us the information, it is difficult to find counts, patterns, or observe what the data is trying to tell us. So that's why we will organize this data, this raw data, into a one-way frequency table. Okay, so what that means is we're going to go through and we're going to count how many people chose pepperoni, how many people chose sausage, etc. So go ahead and take a minute with your group and start counting the frequencies for each of these toppings. And I'm going to do the same. And of course, you don't have to highlight whatever makes sense. If you want to go as you're counting to cross them out, that works too. Okay, so anytime you have raw data, you'll be asked to put this data into a frequency table. So you'll only be asked to do this on your homework. Okay, typically on an exam, they're going to give you the frequency table and they're going to ask you questions about it. Okay, so it says a frequency table shows the counts in each of the categories. Okay, we can also make a relative frequency table, okay, or in other words, relative counts, that displays the percentage in each category instead. So if you see the word relative, then that means percentage. So here with frequency, we counted them, okay, and now we're going to find the percentage of each one. So from here, it says to find relative frequency, you take the frequency in each category and divide it by the total. So relative frequency is the frequency divided by the total. The resulting decimal is written as a percentage. Okay, the total number of teachers in our sample is, so we're going to go ahead and add all those frequency numbers together. And then once you add them together, go ahead and shout it out. What number is the total number? And remember, you have your decimals in front of you. You can just type 7 plus 5 plus 3 plus 4, etc. 25? Anyone second 25? Okay, so 25 is the total number of teachers, which means they went and surveyed how many teachers? 25. That's why we have 25 results here. Okay, so for our relative frequency, we're going to take the number that we got in our frequency table and divide it by what? 25. So the first one is 7 divided by 25. So go ahead and put that into Desmos. 7 divided by 25. 0.28. So 0.28, but we have to turn it into a percentage. So how would I do that? Multiply by 100 or move decimal 2 to the right. So this is 28%. Okay, so go ahead and take a minute and do that for the rest. Okay, so write the proportion, so the number over 25, write the decimal, and then convert that decimal into a percent. Give you guys a minute or so. If you want to break it up among your group, you can. You say, hey, I'll do black olives, you do mushrooms, etc. So again, you're taking all the numbers from this frequency table and dividing it by 25. And as you guys are doing that and filling it in, I'll start filling it in as well. Okay, in that yellow jug. Yep, perfect. It's filled with hand sanitizer. Yes. Yes. Mm-hmm. Okay, so as you are finishing up filling in the table, make sure your numbers are correct. So the numbers should match the ones I got up here. Notice that I highlighted the answer. So if you were to fill in a relative frequency table, the work that you put there would not count as the answer. Okay, so you can show your work, but you need to make sure that you box or highlight the percent, because a relative frequency table is always a percent. Okay. So thinking of that, what do you think would happen if we added all those percentages together? It should equal 100%. So it says percentages, relative frequencies, and ratios all express the same idea. They all describe a proportion of the whole. So percentages, relative frequencies, and ratios, proportion of the whole. Okay. So anytime you see any of these words, just know that they are all representing the same thing. So it says a percentage is a proportion expressed out of 100. So that's why when you got your decimal answer, you multiplied by 100 or moved the decimal 2 units to the right to convert to a percentage. And we said that if we were to add all those percentages together, it should get close to or exactly 100%. Okay, a relative frequency is a proportion expressed as a decimal or a fraction. And then lastly, a ratio compares the numbers in one category to the total numbers of individuals. So notice when we wrote our answers in all three forms. Okay, so the percentage is what I highlighted in blue. The relative frequency is the decimal. And again, I'm going to color code. You don't have to. And then the ratio is that initial fraction. So even though they all represent the same thing, if they're asking for the ratio, are you going to put the percent? Yes or no? No, if they ask for the ratio, you're going to put the what? The fraction, right? That's why I color code it. Help you go back. If you're a visual person, maybe you should follow along in color code. And I'll give you a minute to catch up to that. And then the next example, we're going to be collecting data. So again, even though all those words mean the same thing, depending on what it's asking, so especially on your homework, you need to make sure you're writing it in the correct way. Okay. So let's go ahead and collect some data. So notice I have 5 categories down here. I have cat, dog, fish, bird, and other. So it says, what is your favorite pet? Given the following list, pick your most favorite pet, and we'll tally up the class data. So this is how I'm going to collect the data. Okay, you have to choose only one, which means I should have a total of, how many people are in the class? 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 26, 27, 28, 29, 30, 31, 32, 33 in the restroom. So 33, a total of 33. You are only picking one animal. So if you like cat and dog, you need to choose which one's better. Okay? So raise your hand if your favorite animal is a cat, so I can tally you up. So very high, so I can count you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So go ahead and write 11 for cat. Okay, raise your hand if your favorite is dog. Okay, super high, super high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. Okay, raise your hand for fish. Poor fish, 0. Okay, raise your hand for birds. Poor birds. Raise your hand for others. If I didn't mention a pet you like, raise your hand. Okay, 1. Okay, so that's 30. Okay, good. That works 32 because we have one in the restroom right now. 32. Okay, so it says express the proportion of cats 3 different ways. Okay, so again, we said the total of all this is 32. Okay, so with your group, go ahead and just looking at cats, go ahead and write this as a percentage, a relative frequency, and a ratio, and then compare with your group. Okay, and remember, you got Desmos in front of you, so use your Desmos. If you don't have Desmos, look off somebody. Okay, and then I'm going to tell you, make sure you, if there is a decimal, round to 3 decimal places. So let me write that off to the side. Round to 3 decimals. 3 decimals. And I'm going to trust your guys' math. Okay, so let's look at ratio. Let's start from the bottom. Ratio. How would that ratio look like? (11/32). Okay, I'm going to show you another way. Is this the same thing? Yes, it is the same thing. These are 2 ways to express a ratio. These are the same. You can express it as a fraction, okay, or I don't know the terminology for this. It's just ratio, I think. But just so you see it, you can see it on a question in both ways. Okay. So from here, what is the relative frequency? What is the decimal value? Let's see table 5, group 5. 0.344. Everyone agree? Okay, good. 0.344, which means this is what as a percentage? 34.4. That means as a class, 34.4% of you favor cats out of all the other animals. And so what we're going to do is we're actually going to write that out in a sentence. So number 1 says approximately what percent of cats are the class favorites? So if you see the word approximately, I want you to round to the whole number. So what percent is it going to be? 34. We're rounding to the whole number. So we're going to say approximately, and you can abbreviate approximately as APPROX. 34% of our class favors cats. Okay. So now the second question, it says, can we say that, and we're going to write the percent that we got, 34% of everyone in this school favorite pet is cats. So go ahead and discuss with your group. Why or why not? Can we say that 34% of the entire school's favorite pet is cats? Okay, good. I should be hearing those vocab words. I'm hearing sample. That's good. Okay, so ask yourself this. Is Miss Marco's first period dual credit statistics class a good representation of every student at this school? No, why not? Everyone has different preferences. What would you say the typical age group is for this class? 16, 17, 18, because typically you guys are all what? What grade level? Juniors and seniors. So since you're all juniors and seniors, would we be able to represent a freshman? No. So we're going to say that we can't, since our sample is only statistics dual credit. Okay. This doesn't represent the entire school. Okay, so the big idea here is that if we want a sample that's going to represent the entire population, our sample needs to be random.